All right, let's take a look at 1c. And it says we've got a function of this thing here that has a minimum turning point when x is 1. What are the coordinates of the maximum turning point? So let's first of all write this out. So we've got an f of x, all right, 1c here. Here's 1c. So an f of x is equal to 2x cubed plus kx squared plus 5. Now, we know where the turning point is when x is 1. So if we throw an x as 1, we differentiate, put an x as 1 into here, and make this equal to 0, then the value of k should pop out. Let's try that. So f prime x is going to equal, that's going to be 6x plus, it's going to be 2kx. Now we're going to put in a 1 into this, so it's going to be f, sorry. This is the differential function. So if we make that equal 0, and we put the x in, we'll find out so if I put a 0 in here now, pop the x for 1, 6 times 1. Oh, gosh. Sorry, this is going to be a squared as well. I'm just looking at this. I just got a bit too excited there and tried to get to it through quickly. This is going to be 1 squared plus 2 times k times 1. And then we're going to find the value of k. We're going to solve for k. What's that going to be? Well, this is going to be 6 plus 2 times 1 is going to be just 2k. So 2k must equal negative 6. And if I divide both sides by 2, lo and behold, we're left with k, which will equal negative 3. So there's our k value. So let's go ahead now and rewrite this with a k value in, make it equal to 0 again, and then solve for x. And then we should have two values. One of the values should be x is 1. The other values, so that's the minimum, the other value should be the maximum. Well, let's see how that plays out. So here's our f of x again. This time we've got a value for k. So so I'll put therefore f dash or f prime x is equal to 6x squared. Oh, and it's going to be minus this time as well. Oh, and I'll put plus for now. Plus 2 times negative 3, because I've got my negative 3 and I'm just going to put that straight into here, times x. All right. So that is equal to 6x squared minus 6x. And I'm going to make this equal to 0. Now, let's go ahead and we're going to factorize. Well, first, actually, I'm going to divide everything by 6. Divide everything by 6. So 6 becomes, and 6 against 0 is 0 times is equal to, this is just going to be x squared minus x. So if I factorize that, I got 0 is equal to x, and I got x minus 1. So so this is for the turning point, when the gradient is equal, because that's the gradient, m is equal to 0, either x is equal to 0 or x is equal to 1. So there's our x is 1. And we knew that from the start, right? We were told x is 1. But what's the other one? The other point must be 0. Now, we should probably just test to make sure that's true. So I'll go check second differential test. And we're going to test both of them and see where they come out, yeah? So first of all, let's test the x is 1, and that should be a minimum. It says here it is a minimum, yeah? Minimum when x is 1. Let's make sure that's true. So second differential test, so f double prime x must be equal to, that's going to be 12x minus 6. All right, let x is 1. So f double prime x is equal to 12 times 1 minus 6 is equal to 6. So therefore, f double prime x is going to be greater than 0. Therefore, I'll use the symbol for therefore, I think. Therefore, f of x is a minimum when x is equal to 1. Now let's do the other one. So let's go, I'll make some space at the top here. F double prime x. This time we're going to try and put in the other thing, where x is 1. We've done that one. Now let's go x is 0. Let's try that one. Now this should be our maximum, but let's just confirm it is equal to 12x minus 6. Let's go ahead and go let x is equal to 0. So we've got f double prime 0 is equal to 12 times 0 minus 6 is equal to negative 6. So therefore we can say because, running into difficulties here, because we can say f double prime x, or f double prime 0 is less than 0, f of x is a max at x equals 0. All right, so we've now kind of found that to be the case. But the question actually, if I go back to the question and have a look at it, it says, what are the coordinates of the maximum point? So we've proven now that this is in fact a maximum. So let's go ahead and say, let's find the coordinates. So we're going to say, I'll choose a sharper pencil here. Find coordinates of max. So the coordinates of the max is going to be when x is 0. So here's f of x, but we're going to find f of 0, which is, and we've got the original here, remember, 2x cubed, blah, blah, blah. And we've actually got a kx squared in there as well. It doesn't really matter. You can just, k is negative 3 or whatever you want. It doesn't really matter. I'll put actually, we now k is equal 0. So I'll put that in there. So we've got 2x cubed minus, and it's going to be a 3x squared plus 5. But I'm going to put zeros in for that. So equals 2 times 0 cubed minus 3 times 0 squared plus 5. Therefore, f of 0 is equal to 5. So that's our y, yeah? So now, coordinate of max turning point is 0, 5. And that's how I would go ahead and find that.